I'm Murray Oldfield. I'm a technology architect at InterSystems. So what I do is I work with vendors to understand their technologies, and we do things with them such as benchmarks to understand the capabilities of the platforms, how they fit with IRIS, any sort of changes that we might need to make, or any recommendations for tuning and configuration and so on, and try and pass those on to the customers and keep the customers informed so that when they do implementations on whatever technology we're talking about is, let's hope that stops soon. So my job is to talk to people like you and just to be an advisor as far as implementing these technologies. I also try and do help with capacity planning and those type of things. This session is about hyper-converged infrastructure, or HCI, but it's a summary of some work we did with VMware when we were benchmarking their VSAN hyper-converged infrastructure. Now, I'd point out that a lot of the lessons we learn from one vendor pay off for another. So some of the things that we're going to talk about apply across the board for HCI, and I'll try and highlight those as I go through. So they also mean the same things. There's analogs, whether you're deploying Nutanix, for example, and we're starting to explore other HCI vendors as well. So if you have any questions, certainly interrupt me. I'm more than happy to stop the presentation and address something if it's timely, and I'm going to be available afterwards too. So VSAN's hyper-converged, and what that really means is hyper-converged is all about software-defined storage. So if there's one thing amongst the vendors that is common, it is this idea that we've got rid of the storage array and we've collapsed everything into the servers. So disks are nice and close. So NVMe drives are sitting on the PCMI bus, so they're nice and close to the processing, and everything else is inside the machine. But that also brings some challenges because the data has to be spread around across the host for availability and reliability and those type of things. You can buy it as a complete unit from the vendors, or it's sold as a software-only solution. Now, when it's sold as a software-only solution, that means you're bringing your own hardware. So you can go off and buy some Dell R730 XDs and populate them with NVMe drives and SSDs and so on. But you really have to be sure that if you do that, everything is on the vendor's hardware compatibility list. That goes right down to HBAs and firmware on the drives and operating systems and everything. And I really want to make that point because I've certainly run across it in benchmarks where we've stuck something in as a stopgap while we were getting kit built up, and we've had issues, and we've also had feedback from our support organisation that customers have had issues where they've had equipment that wasn't on the hardware compatibility list, so it can come back and bite you. So back in the day, we used to have a shared storage array with disks and LUNs and storage controllers and cache and so on in there. And then all our VMs would share that storage. And of course, you need to share it because your VMs can vMotion around and they need to be able to access the data. Nowadays, it's all collapsed up inside. So we still have the same requirement though. We still need to be able to share the data across that data store. And if that VM vMotions to some other location, then that data still has to be visible. And that's all handled by the network, which is very important, and also by obviously whatever the software-defined storage is, whether it's VSAN or Nutanix or something else. So the key there is though that your data could end up on any host, not just the local host, and that's a bit counterintuitive for people. The fact that host 1 writes to its data to the storage on another host is just the way this stuff works. And if your networks are set up properly, these things just do work. And so, the way I sort of tell myself is that, except for some special cases, which I'll talk about, Nutanix and VSAN and these people, VMware, have very smart engineers to write very smart software to make this stuff work properly. Put a human like me in the middle, and things are bound to go wrong. So that just works. So for the VSAN benchmark we did, we ran a couple of benchmarks a little while apart. One had 4 hosts, one had 6. But the things that are in common are that for VSAN you have multiple tiers of storage. So we have, as you can see there, zooming in, we can see we have a cache tier and a capacity tier. For an all SSD, all flash implementation, all your writes go to your cache tier, all your reads come off the capacity tier, except for maybe something that's just recently been written. The cache tier and the capacity tier setup was there because back in the day you could put spinning disks there. And I say back in the day because I don't want anybody here to go out and implement today with IRIS or Cache and have spinning disks in their solution. We've got to the point, the great 2017 SSD shortage has passed. SSDs have come down in price, the capacity's gone up, and certainly you can get the capacities you need. So there's no real reason to go to spinning disks. And certainly for your high transaction rate business critical applications, you really do want the fastest storage possible. The other thing that you can see there is there's multiple disk groups in each host. And that means that the way VSAN works is you have one cache tier disks, in our case NVMe, so very fast, very low latency, and some number of capacity disks. And that's the setup they have. So by having multiple disk groups, we can get more NVMe in each host. We can do more parallelism in our writes. And we're also making availability regions within the host. So if there was a failure of the SSD disk group A in host 1, it's taken out only a subset of whatever was stored on there. It also makes things like rebuilds and things a lot faster because we're only dealing with a lower number of bits of data that have to be rebuilt. When we did our benchmarks, we set the systems up as I would like you to deploy them. So we didn't turn this into a drag racer and pull off all the bodywork and take the seats out and try and make it go as fast as possible. What we did is we set it up as we would expect a customer to set up a production system. We ran with 2 disk groups, and probably over time we will probably experiment with that and see if different numbers of disk groups and things. And what comes out of that is our advice to you. So I'll write something on community if we change our recommendations, for example. So where is my data? So this slide is just to show you what I was talking about before. We might be on host 2. I write my data, and it's going to be at least RAID 1. So there's going to be 2 copies of my data and a small witness component to stop. In the case of split brain, if there's a network isolation between host 1 and host 2, who's really got the data? What that means, though, is that we're increasing our actual capacity for your capacity planning, because if you were writing 2 terabytes of data before, now you need to store 4. So the benchmarks we ran, first off, just scale up. So this is what most of our customers deploy. They just have one VM, which is their central database, and it scales up to however big you need it. One of the rules of VMware sizing is right size your VMs. If you need 8 CPUs, make your VM 8 CPUs. Don't just fill up your whole. Say I've got 24, so I'm going to use 24. But you can. And so in benchmarking, what we tend to do is we want to see what happens under normal situation and normal operation, but we also want to see what happens when you scale up as far as you can, because that's when the edge cases come in and that's when things can get interesting. So the first test we ran, we just simply scale up. We step up the size of the VM and understand the workload and what it has effect on I/O and so on. So one of the tests we run is something called random read. Now, if you go out to the community, InterSystems community, how many people here have visited the InterSystems community website? So a few. I'd recommend that you do go there. It's just community.intersystems.com. If you search for my name, you'll find a bunch of articles there, and I talk about things like sizing and so on. If you search the community for RAN read, you'll find this utility I'm talking about here. And what it does is it just runs a process that does, we created a big database, so spread wide, and then we do random read I/O on it. And what we use it for is it's a nice smoke test to understand how the storage underneath is configured. We use it when we do deployments because we want to make sure that just a quick smoke test to see that everything's been set up properly. When we run the random read, we run a certain number of processes. Now, if you run one process and you've got 0.5 millisecond latency, the most reads it can possibly do is about 2,000 IOPS. So if you ran 10 processes, you're going to get 20,000 and so on. And so we keep increasing the number of processes to understand where the limits are with the storage, for example. What we run out of, typically with SSDs, back in the day when we were doing spinning disks, we would see the latency go through the roof and we would hit a certain number of IOPS capable. Because as the latency goes up, your IOPS can't go any further. But with flash storage, you have way more than most applications require. So in this test, I was simply running a single VM, and I ran it up to about 24 virtual CPUs. I ran it up to about 50 processors, and it was doing about 120,000 IOPS. Then I just ran another VM on another host, same size, 24 CPUs, and we can see that the number of IOPS is the same on the second one, so effectively double. And the thing is, the nice thing about this software-defined storage is it's still kept up. The latency for both VMs was the same. So that was a good smoke test. And where this comes into play is what I'll talk about in a little bit when we talk about things like IRIS and sharding. And if you're doing a lot of reads, for example, in parallel, you want to know that it can happen across machines. So the other architecture that we have, of course, is scale-out, or ECP. The thing about ECP is the database server is the one doing all the I/O, and the application servers really aren't doing any I/O, they're just processing. But the nice thing to see here is that even as we drive that one VM harder, it's still kept up. So in this chart here, the single database server was doing 2.7 million database accesses, or as we would call them, glowrefs, per second. And that's about where it topped out. So that's about the size of probably 2 or 3 large metropolitan hospitals worth of workload on one VM. But using ECP, now we can scale out horizontally. So by adding application servers, we're increasing the number of glowrefs, but what that really is indicating here, we're increasing the number of transactions we're doing. So we're scaling nicely. As we add application servers, we're just increasing, and that just works as well. So you can actually scale out on these type of platforms. The other thing that InterSystems IRIS has is sharding for SQL queries. Now, there's other sessions around about sharding, but the interesting thing is that we also took the opportunity to run benchmarks on sharding as well. So as your applications change over time and you start to take advantage of these new InterSystems IRIS technologies, it's nice to know that they work as well. And the testing we did, running on a single VM, on a single host, it took around about 100 minutes to run a set of queries based on an industry standard called TPCH. And what this is a bunch of complex queries that run one after the other, and they involve different scenarios and so on. But by using sharding, which is a way of distributing your database across multiple databases and multiple hosts, we're able to significantly cut down the time. And that's what they were talking about in the keynote this morning, this idea that you can do this parallelization with your queries and bring back results extremely fast. So this is where we're going with IRIS. And you can see that it's about a 5-to-1 ratio once you start doing this type of sharding. And I would probably put on that slide something like your mileage may vary, but I think it's important to know that now you have this capability in the box with InterSystems IRIS. And sort of to prove the point as well, I guess, because the way like a SQL query is a lot more simple than the transactions, we're seeing about 34 million glow refs from a single VM. But when you start to scale out, we're up to 120. Obviously we're just doing more work. But we're getting this massive scalability now. Now it might seem a funny time to ask, is VSAN actually supported? The short story is yes, because what we do is we support operating systems and processes. So the fact that it's running on a virtualized environment, we still support it. That's been like this for a long time. Whether it's on VSAN and Hyper-Converged or whether it's just plain virtualization, we're not going to ask you to prove your problem on bare metal. If we have to back end with the vendor, we will to understand if there is a problem at that level. But are there any special considerations for Hyper-Converged? And yes, there are. This is a new sort of technology, and I equate it to where we were maybe 5 or 6 years ago with virtualization, where a lot of the InterSystems customers, people running big databases, high transaction rate databases, were just starting to move on to virtualization. People weren't sure what best practices were, how to size it, how it would, what shape it should be. And a lot of the work that I did, over those intervening years was trying to understand how virtualization like VMware worked with with Cache. And now we're doing the same with Hyper-Converged. And as we work with the vendors and as we get feedback from customers, we are bringing out special considerations. In fact, I wouldn't call them considerations. I would say they're requirements. So this page is on the community. If you search for SDDC, I'm sure you'll find that page. And this lists off some requirements that we found are needed for Hyper-Converged. Now, whether it's VSAN or Nutanix, the requirements actually are pretty similar. And we'll talk about a few of them as we go through. So, for example, what do we need from a database? We need performance, so we need consistent low latency I/O, we're talking about storage here, and we need resiliency, the ability to recover from failures. So that's where your basic VMware HA comes in, but also the underlying technology of the Hyper-Converged infrastructure itself. So what are the lessons we've learned and the things that were summarized on that page? You have to select the right components, properly configure them, and so on. So we'll go through some of that. So for compute, really the place you should start is the VMware best practice. If you're looking for an order of precedence, basically we're running VMware here. So whatever the VMware best practices are, and I've done several white papers on that specifically for InterSystems data platforms, that's your first thing. And then we layer on, okay, now there's some special things for HCI. So we want to remember all that processing that was happening down on the storage tier with your storage controllers and its read-write cache and all the smarts that were built in. Storage arrays nowadays essentially have, servers in them to do all of that processing. And so we've moved that processing up into those hosts that make up your VSAN cluster. So you need to leave some capacity for that. So do your capacity planning. If you leave 10%, that's a good ballpark. We also specifically say current versions of Intel processors and later. And there's several reasons about that, but it's basically the support for virtualization that's built into those, the performance, because they're faster and faster, and the fact that it has to do all this other processing. Over time, that page may get updated with different things. We're doing some benchmarking with AMD in-house at the moment, and so there might be a time when we have some recommendations around that too. But we can only recommend what we've tried or what we've found out from our customers. That recommendation for the RAM is actually more to do with the type of processor. It just has 6 memory channels, so you have to populate them all and they go faster. So being an in-memory database, we want the memory stuff to go faster as well. Networking. Networking is absolutely key to this, and people sort of seem to forget, well, I'll just plug it into the switch and everything will be fine. But remember the big picture here. If I write my data, it could end up on my local host, or it could be a copy somewhere else, or there could be copies nowhere near my local host. So when I read and I write, how does that data move around? Well, obviously over the network. So we have some very specific requirements around the networking. VSAN for an all-flash, the minimum is a 10 gig network anyway. But it's got to be non-blocking. It's got to be wire. You can't have storage slowed down, otherwise your database slows down and then your phone rings because you're complaining. As you invest for the future, as you're doing your hardware refreshes over the next year or whatever time frame, now might be the time to start investing in the network topology as well, specifically for the hyper-converged, but your organization requirements. So for the storage, all flash. I've said this a few times, and I'll just keep saying it. There's really no reason, economic or otherwise, not to do it, and certainly you want the performance. For this, disk groups per node, and like I said, change that, but that model, we got the performance we required out of that. For the capacity tier, we recommend SAS SSDs once again for performance, and NVMe for the cache tier. The next thing there, talking about LVM striping and async I/O and so on, I'll talk about a little bit more in a minute. And the other thing, the separate PV SCSI, is more of a general VMware best practice. So PVs, when you define your VM, you can have multiple PV SCSI controllers. So your disks attached to these controllers, essentially. If you can split up your disks across those SCSI controllers, they're virtual ones in VMware, then you're going to get a bit more space, and you're going to get better isolation, for example, between your journals and your data, perhaps. So on my community pages, I go into this in a bit more detail, but this is actually, these type of things, we're just trying to optimize the storage. So these are the sort of things that I want you to take advantage of. So in vSAN, data is stored as objects. There's always at least 2. The objects themselves, so they call it object-based storage, but the objects themselves are up to 255 gigabytes in size, but that doesn't matter. If your database is bigger than that, you'll just get more objects. It's all transparent to you. But I'm telling you this for a reason, and that reason will become clear in a minute. And this is the picture we saw before, where, table stakes for these type of solutions are at least RAID 1, 2 copies of your data, because if you lose a host, you lose your data if you've only got one copy. So for production systems, we in fact recommend failures to tolerate as 2. That means we could lose, have a network isolation, but with host 1, and we could have a complete host failure of host 5, but you've still got a copy of your data to keep working with. Once again, when we ran the benchmarks, we ran them in this configuration we wanted to. But the thing to realize here is now we've got 3 copies of your data. If your data is 6 terabytes, 6 3s are 18 is going to be stored. So you have to account for that. You can grow your number of nodes and things and increase the capacity, but these are important things which are a little bit different. I think we're all used to RAID on storage arrays, but it's the same concept, but you can't forget it. The other thing, another term is called erasure coding, but really that's just RAID 5 or 6. So if you have failures to tolerate as 1, then it will use RAID 5. So you'll get multiple copies of your data, but the important thing here is that your total, because we're using just RAID now, RAID 5, rather than RAID 1 in multiple copies, suddenly your storage requirements come down. So this is great for non-prod, for things that aren't business critical, that don't have to be rebuilt very fast. So one of the things I haven't really talked about is that one of the key features of hyper-converged infrastructure and software-defined storage is you can define the policies of your VMDK or your VM or your VMDK individually. So I could say within one VM, I want my journals on this type of policies like failures to tolerate as 2 and so on and so forth, and I want my backup area just to be RAID 5. So you can actually have that granularity now, and that's just a byproduct of it's software-defined storage. They can do a lot more things, and as the new versions of these software come out, they can add features. So things change a lot more faster in this than they used to back in the day. So failures to tolerate is set to 2, would give us RAID 6. Now, the other interesting thing about this picture is that we've said failures to tolerate is 2, so we're going to get 1, 2, 3, 4 copies of the data and some parity bits. They've all got to be on separate hosts. So now we've got a minimum number of hosts. So these are the other things that were perhaps not obvious from those previous pictures. So if we go back and have a look at this one here, if I'm going to do FTT equals 2, then I'm going to need a 6-node cluster because I've got 1, 2, 3 copies of data, 2 witnesses, and n+1. So if I want to do maintenance, you can possibly get away with 5, but that's your entry level. So these are things to consider. If you're buying VSAN or Hyper-Converged just for a single application, there are minimum numbers. You can go much bigger, and so if your organization is using HCI and they've said you're putting your cache or IRIS application on here, and we've got a 16-node cluster, well, all's fine. But if you're just putting your EHR on this one contained thing, then there is a minimum. So here we go, the storage-based policy management. So these are the type of things that you can specify right down to the VMDK level. So you could say my journal disks are this, or my data disks are going to be this policy. So we can set dedupe or compression. I recommend that you don't turn it on. There's an overhead and there's no real gain, because if you think about it, everything here is for production. For your non-prod and stuff, dedupe might be great because you've got lots of copies of things. But for production, if you think about a database, the individual 8K blocks or 32K blocks, whatever they are going to be full of unique information with pointer blocks and things which aren't going to dedupe. So why do that? Encryption, just go at the lowest level. If you need your you're worried your cache.dats are going to be stolen, then encrypt using IRIS or cache's encryption. the hyper-converged platforms also have encryption built in, so you can sort of encrypt at lower levels if you don't want to do that. Object space reservation just simply means thick or thin provisioning. So I recommend that you thick provision on vSAN, not for performance reasons, but for the layer 8, the management reasons. The reason that you might have scoped out how much storage you want for the next 3 years, and then it's thin provisioned, and some other noisy neighbor application has just decided to eat all the storage on your SAN, your vSAN. So it's more to do with just staking your claim for your primary systems. And as I said, failures to tolerate too. So I'm going to talk a little bit about I/O. So this picture should be quite familiar to people who use cache-based applications. We've got our reads bumping along with the orange graph. Because we're an in-memory database, typically we try and size things to have as much memory as possible and therefore as much of your working data in memory. So the reads can be quite low. I work a lot with the TrackCare application, which is an EHR system we sell outside the US. So so I do a lot of work with capacity planning for them. And this is, in fact, a typical customer. Seeing about 2,000 IOPS is not an awful lot, but it's actually quite typical because if you think about a hospital working set, same people are in hospital. You might have inpatients and outpatients, but all your code table and doctor lists and all of those, they're all the same, so they just stay up in memory. Your application may be different. If you're doing a big report, you might see a big spike in those reads, for example, and that might be a reason to go and look at that report, but this is quite typical. The other big spike there is the writes, and every 80 seconds or so, cache will get all the change blocks in memory and write them out to disks. And there's another little blip in there which is sort of a little bit hidden, but just before the WIJ, the write image journal, gets written out, a big sequential write. The reason I'm bringing these things up is because when we started working with hyper-converged vendors, this can actually upset I/O and storage because we're doing reads are nice and easy. Our journals are probably bumping along sort of at a fixed rate, but suddenly we get this giant burst of writes at the same, and so what that can do is interrupts probably the wrong word, but it can interfere with the way that the reads are working. So on the graph on your left there, what we've got is IOs on the right-hand side of the y-axis, and on the left-hand side we've got the latency, milliseconds. So we can see the reads are going along on that little orange graph there, and every 80 seconds the write daemon's going off, so we've got about 9 of them in this little snapshot of time, and we can see that the average weight on that orange graph shoots up every time the write daemon goes off. And this is just something we noticed happens. What we did is, one of those requirements we put on that community page is to, if you're using Linux and Red Hat, you can do something called LVM striping. So what that means is you have multiple hard disks or VMDKs defined, and you can stripe across them and make a single, what looks like a single disk, but in fact is multiple disks. And if you make them at those 255 gigabyte sizes, the way vSAN works is it'll spread them out as well. And what that gives us is a nice parallelization as we do our writes, and that smooths out the impact on the reads. So for example, what we saw there is the read A weight is in the blue chart is after doing that. So before is the orange chart with the big spikes, and after is the blue with the much less impact, much smoother graph. What does that mean? It means your reads are coming off a lot cleaner. It means that users waiting on a screen are seeing good response times. And this LVM striping is something that we recommend across all HCI vendors, in fact. So we do the same with Nutanix. This just goes into explaining a little bit more about what I just talked about. The key point here is that, if we have a 2 terabyte disk, so I break it up into like 8 pieces, so we get this parallelization. So it depends on a little bit on the size of what storage you're working on, but we recommend that you start at 8. They don't have to be exactly that. And this is the effect we saw. So on the left, the IOPS we're getting in the blue chart is after turning on the P striping, and on the green is before. So we're getting a much lower latency, as you can see on the right-hand chart, and of course that just translates to IOPS. So this is the sort of work we're doing with the vendors continuously. So as we keep working with them, as more and more customers come on board, we will make more and more recommendations. And we may change recommendations based on changes the vendors make to their technology as well. And there's a white paper on the community that tells you exactly how to do this. So that's me, got to the end. InterSystems.com. If you just search for capacity planning or capacity planning and performance series index, you'll get to my corner, which has things like best practices for deploying VMware, and like I said, more and more things about Hyper-Converged on there as well now. And with that, I'll remind you of my summary. I've got things back to front. So the review the advisory, please involve all the stakeholders. So if you're dealing with VMware, get them involved, get us involved. We're more than happy to talk to you. If it's Nutanix, do exactly the same. All flash. If you're going to be buying your own storage, please, please, please make sure that everything's on the HCL. And if you've got some new drives in there and the firmware patch comes out from the drive vendor, you have to check with your HCI vendor whether they have tested and improved it already. You can't just go and install it because things might not work afterwards. And if you have any questions, I'm more than happy to answer them now, or you can come talk to me anytime at the conference. Yeah.
So, scenario being cache, single server, and fairly state-of-the-art SAN.
Yeah.
Would you consider it worthwhile to look into putting, say, Bridge and cache temp on flash store?
So I'll repeat the question. So this is not an HCI question, but just like general. The interesting thing is the things that we found out to optimize HCI can be applied to any storage. We found that, we were driving these benchmarks hard. We were pushing the limits in a lot of cases. So we were trying to find where things need to be adjusted. But out of that, so what I was talking about, if you've got, those improvements will work. If you're running VMware, put them on separate PV SCSI. If you can put your wedge on SSDs, do that too. What do you reckon, Mark? Yes.
Especially applicable for the single storage formats like Sharding.
Yeah, you definitely want to put in separate processes the wedge, because the wedge will, they're large writes, they're 256K writes. That will wreak havoc, especially on an HCI platform, because HCI platforms like really small IOs. SAN storage arrays that have controllers and whatnot, they tend to absorb it a lot better. But in an HCI situation, you definitely want to have it at least on a separate DMDK, if not a separate PV SCSI controller. Typically, what we like to do is you split up your sys, your install, your databases, and then your journals. The sys install would also contain your wedge and your cache temp as well, so that way you're isolating your IO habits.
There is,
On a Unix box, just do it A to B, G, and join. And it'll be runs under default, 2 hours.
Yeah, that'd be fine.
yeah, so don't change things just for the sake of changing them. But if you are starting to have performance issues, we've learnt some lessons that might get you that little bit further. Okay, cool. Thanks very much.